Hi, this is Jeremy Bryden with coreBasic Software Solutions. Today I'll be doing a follow-up video for my coreBasic iOS application that's kind of like an IDE, so an integrated development environment, so you could write your own applications on iOS. Now remember, it's important to distinguish that this application doesn't actually allow you to create independent executables much like other applications that you might install on your device, but it does run its own syntax. You can go ahead and email this code to maybe a friend, and you could also load and execute resources within this entire sandbox environment. So you'll see here that there's a couple of new features, notably is the trash. So if you go ahead and delete something, it'll be saved in the trash folder. We could also hit the I button for a manual on the language. Now, right now the manual looks bad, but the content is there. We'll play with formatting a little bit later on. Now we could go ahead and open up a source file. Let me full screen this. Something you'll notice is that I've changed the buttons around a little bit. We now have an edit menu, which you could undo and redo changes, explicitly save, even though it saves every time you run the code, and then also quit button, so you could go back to the main menu. On the bottom, again, you'll also see a new debugging system, so you could write lines and the program can interpret that. There's also a screen emulation system, so when you write code that displays lines or whatnot, you could click on that, full screen it, or you could leave it alone and just watch it from the bottom left of the application. And on the right and the middle left are memory viewers and instruction viewers. So the code that I'm about to load, it's purely a test sample. The first command is clear, so we go ahead and erase the output screen of the graphical output, so not the text output. Then we create a variable offset. We set it to 0. We create a for loop from I to 1000, and we only increment once per loop. Then we write to positions on screen. So essentially what we're doing is a diagonal line that loops back based on a modulo operator. We display the number that we're trying to draw, and then we do a \n, so a new line. And then the rest of the code is just to show that you could scroll up and down. I've also enabled debugging, so if you want, you could click on one of the numbers, one of the line numbers, and activate debugging. So hit it once, it'll put a breakpoint there, hit it again, turn it off. What's also new in this version is if you hold long enough, you could go ahead and resize the text editor and then also the instruction viewer. And the same thing happens for the bottom. So if you hold down for 2 or 3 seconds, you could go ahead and stretch it out. So let's go ahead and run this code. We'll hit the run button. You'll see, if I scroll down on the bottom left, that there is graphical output. It's only drawing a couple of pixels at a time. It's also varying the color. So we let the user go ahead and do real graphical output rather than keep it with just standard input-output on a console. But if you want, the console is ready to go on the bottom. Again, I could type whatever I want during runtime. This specific code doesn't interpret anything, so it's kind of useless. And as I've mentioned before, there is a static memory analysis on the bottom right. So here we could scroll down. We see all of the 0 integers that are being loaded into memory because of each explicit display call. Every time that there's a reference to a string, so you see in the source code here we have a \n, which is its own string loaded into memory. You can see how it's referencing, at memory index 48, there's a reference to a string 376, and if you look at memory address 376, you could actually see the ASCII drawn out there. Also, again, if I go ahead and move this to the right, you'll see that the instructions are completely loaded, so you have in this example about, let me scroll down, you've got about 58 lines of source code of coreBasic, and that compiles into about 896 kind of basic bytecode. And you could see the arguments and then what the actual instructions are. Here you could see the modulo being applied on this line, just like in the line right after the for loop. We could go ahead and stop the application, quit. We can maybe load up another example or maybe another challenge and execute that, and you see that everything is now working well. It loads up this smaller example. It executes it. It prints out 1 through 10 using simple go-tos and labels. And then I think one of the big features that we'll be focusing on is allowing the user to actually step through using the keyboard. So what I mean by that is not the on-screen keyboard, but it actually would be nice if we could do shortcuts with the physical iOS keyboard that I've seen a lot of people actually walk around, and when they sit down at, let's say, Starbucks, sometimes they pull out a physical keyboard, and it'd be nice to allow people to do, Command O for stepping over, Command I to step into, rather than doing it through these top right 3 buttons. So this is Jeremy Brighton. If you have any questions, please visit my website at cores2.com. Thank you very much for watching.